students, in this part I'll be telling you some properties of the p block elements. In this I'll be teaching you about electron affinity, metallic character, ionization enthalpy. Also I will tell you something which is known as diagonal relationships, which you must have observed in S block elements also, okay, between alkali and alkaline earth metals. So here also that kind of similarity is present. So let's see, here we go. Hi students, next we'll move on to the properties of p block elements. The properties of p block elements, which I told you, which may be either physical or the chemical properties with different equations also, with different properties also. So let's here begin. So the first property is electron affinity. How electron affinity will change, what happens, let's see. So electron affinity, it will increase from left to right among the p block elements and it decreases from the top to bottom. This we already know from the classification and periodicity of elements chapter, right? That if I move from left to right, then my electronegativity will always increase because it will have the tendency to accept the electron more quickly. So it will increase. But there is some exception here. Group 15 is having exceptionally low values of electron affinity, and this is due to what? Your extra stability. If you remember in the chapter of structure of atom in class 11th, okay, you must have read half filled and full filled are more stable. Your half filled and full filled are more stable. So that's why group 15 is an exception here for the low values of electron affinity, guys. Similarly, your group 18, they will have zero affinity. Why? Because they already have their octet complete. They already have their 8 electrons in the last shell. So they will not, add one more electron. Next property is your metallic character. How my metallic character will change? So it is totally governed by the two factors: size of atoms and ionization energy. So let's see how these factors govern it. Now the one which has bigger size and low ionization energy obviously will have the greater metallic character. Low ionization energy means what? It means that I have to provide very less energy to remove one electron from it. Okay, and if it is a bigger size, that means that electron on the valence shell, it is very less attracted towards the nucleus. Means the effective nuclear charge is totally, it's totally negligible there. So it will show your metallic character. So the elements with above two properties, okay, they are in the left corner of the p block. They are on the left corner of the p block. On the right hand side, it is not the case. And strong non-metallic are at the right hand side. So non-metallic are on the right hand side. And this is the metallic one. And between metals and non-metals, there is something which separates these two and which shows the properties of both actually. Okay, they can behave like a metal also, they can behave like a non-metal also, and they are known as metalloids. They are known as your metalloids, guys. Next property is your oxidation state. So oxidation state will vary, right? Here it's written also that it shows variety of oxidation state and there can be both positive or negative. So it totally depends upon the inert pair effect. Okay, so where there is lower oxidation state is more predominant. If I have lower oxidation state, okay, so that means I have either less electron which get released from it or less electrons which get added to it. This is the case. So in this, your inert pair effect will affect a lot to my neutral atom. Then the relationship which I told you, the diagonal relationship also, which is observed here, like in S block. So on moving diagonally across the periodic table, the element will show certain similarities. What is the similarity? Your lithium will show similarity with magnesium, beryllium will show with aluminium, boron here shows with silicon. So here is also the diagonal relationship getting observed. Now let's conclude the whole properties of p block elements. So atomic radii, if I go along left to right, it will decrease. Okay, it will decrease, and top to bottom obviously it will increase. Similarly here you can see ionization potential. If I go along the period left to right, it will increase, because then more number of electrons are present in the valence shell and I have to provide more energy to remove those electrons again. Okay, so it is increasing. But if I go from top to bottom, then a new shell is getting added, and due to which it is getting decreased. Similarly is the case of electron affinity. Electron affinity, it will increase. What do you mean by increasing electron affinity? That means that it is easier to pick up electron there, okay, which decreases down the group, Electronegativity, you all already know that it increases if I move from left to right, and it decreases from top to bottom. Metallic character, obviously it will decrease. Metals are on the left side, I told you right now, and it will increase down the group. Oxidizing property, it will increase, and here it will decrease. Reducing property will decrease, and top to bottom it will increase. So these were some of the properties of p block elements. So students, in this part we saw many properties of p block elements, like ionization potential, electron affinity, their metalloids characteristics, their metallic activity. Also we saw their oxidizing property and the reducing properties. And one which is very peculiar thing we saw is about the diagonal relationships. In my next part, I will be telling you about the boron family, So stay tuned with me for that.